Good morning.
Good morning. All right, so the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mail. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. So today we're going to review material from chapter 10. And so let's go ahead and get started. So let's take a look over at, I've got some web assigned problems up there. We're going to look at number, doesn't want to, hang on, I'm trying to get the, let's see here. There we go. Wasn't coming out. Anyway, we're going to take a look at number 2. This is from section 10.1, the square root property. It says use the square root property to solve the equation. And we have u squared minus 28 equals 0. To use the square root property, we need to get the equation in a certain form. We have a perfect square equal to some number, okay? And the perfect square contains the variable. So what we'll do is we'll add 28 to both sides of the equation. So we have u squared equals 28. We have a perfect square containing a variable equals some number. Then we take the square root of both sides, but on the right side of the equation, on the constant side, we do a plus or minus. So now we get u equals plus or minus the square root of 28. But we're going to take the square root of 28 and write it as the square root of 4 times 7. Simplifying it, the square root of 4 is 2 on the outside. So now we've got u is plus or minus 2 square roots of 7. In WebAssign, however, they don't use the notation plus or minus. They separate them into different solutions. So we'll say u equals negative 2 square roots of 7, comma, 2 square roots of 7. So over here, u equals negative 2, and then square roots of 7. And then I've got to move the cursor outside of the radical symbol, comma, space 2. And then square roots of 7. And there are our two answers. Okay, any questions about that? All right, let's go down here and take a look at number 4. So here we have used the square root property to solve the equation. And we already have it set up where we have a perfect square containing a variable equal to some number. So we can go ahead and take the square root of both sides of the equation, including the plus or minus on the right side. So now we get t plus 8 equals plus or minus the square root of 64, which is 8. But we're not done yet because we're solving for t. So we'll subtract 8 from both sides. T equals negative 8 plus or minus 8. So then we've got t equals negative 8 plus 8, which is 0, and t equals negative 8 minus 8, which is negative 16. So t equals 0 and negative 16. Okay. We've got t equals 0, comma, space, negative 16. And let's see what it says. All righty, any questions there? Well, then let's move on and to section 10.2, which was the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It says use the quadratic formula to solve the equation. Enter your answers as a comma separated list. So we've got x squared plus 14x equals negative 49. The first thing I need to do is get the second degree or quadratic equation in standard form. That is ax squared plus bx plus c equals 0. So I'll add 49 to both sides of the equation. X squared plus 14x plus 49 equals 0. At this point, if there were any fractions or decimals or ways I could reduce this problem, I would, but there isn't, so we'll continue on. And we've got A is +1, B is a +14, and C is a +49. So now we'll substitute those numbers in the place of the letters in the quadratic formula, that is A, B, and C. So X equals -B plus or minus the square root of B squared minus 4AC all over 2A. Continuing to simplify, X equals -14 plus or minus, I think 14 squared is 196. Let's find out. Yes, it is. And then we've got minus 4 times 49. 4 times 49 is also 196 all over 2. So X equals -14 plus or minus the square root of 0 over 2. X equals -14 plus or minus the square root of 0 is 0 all over 2. So X is -14 over 2 or -7. So X equals -7, and this is a repeated root. So let's see here, we'll just put in -7 and see what it says. All righty, let's take a look at this problem, problem number 7. Again, as I say, if there's anything you want me to do differently or go back over something or slow down, whatever, let me know. Otherwise, I'll just continue. Use the quadratic formula to solve the equation. 8x squared plus x minus 9 equals 0. This is already in standard form. Nothing I need to do or can do to make it simpler. A is 8, B is 1, and C is -9. So X equals -B plus or minus the square root of B squared minus 4AC all over 2A. X equals -1 plus or minus the square root of 1 plus, because -4 times 8 times -9 is going to be positive. And let's see, 4 times 8 times 9 is 288. That's all over 16. So X is -1 plus or minus the square of 289 all over 16. Let's see, is 289 a perfect square? Well, let's take the square root of 289 and see what happens. It is, it's 17 all over 16. So X equals -1, oops, that's not what I wanted to do, plus 17 over 16, which is 16 over 16 or 1. X equals -1 minus 17 over 16, which is -18 over 16 or -9/8. So X equals 1 and -9/8. So X equals 1, comma space, -9/8. Okay, and let's see here. Let's take a look at problem number 9. So here we're going to use the quadratic formula and then go to the calculator to get decimal approximations for our answers. So we've got x squared equals x plus 7. I could move the x squared to the right side of the equation, but I'm going to move everything over to the left side because I want to have my leading coefficient, that is a, to be a positive number. Just makes it easier to deal with. So I'm going to subtract x and subtract 7 from both sides of the equation. So now I've got x squared minus x minus 7 equals 0. A is 1, B is -1, and C is -7. X equals -B plus or minus the square root of B squared minus 4AC all over 2A. X equals 1 plus or minus the square root of 1 plus 28 all over 2. X equals 1 plus or minus the square root of 29 all over 2. 29 is prime. It doesn't have any perfect square factors. So our two exact solutions would be x equals 1 plus the square root of 29 all over 2, and x equals 1 minus the square root of 29 all over 2. But now we're going to go back and use the calculator. And so I'm going to put in parentheses 1 plus the square root of 29 divided by 2. Okay, so parentheses 1 plus the square root of 29, close it up, close up the whole thing, divided by 2. And I get 3.1925, etc. It said round to 2 decimal places. That would be here. The 2 would round down. So 3.19 should be one of our solutions. And then the second one, 1 minus the square root of 29, the whole thing divided by 2. And we get negative 2.1925, etc. The 2 rounds down, so negative 2.19. Okay, let's see here. So we've got 3.19, comma, negative 2.19. That comes out correctly. Okay, let's go on and take a look at problem number 11. So now we're going to get rid of some fractions. Let's see, let's get rid of this little piece here. Clean up the problem there. Okay, so we've got x squared over 3 plus 5/3 x equals negative 1. So first of all, I'm going to add 1 to both sides of the equation to put things in standard form. Then I'm going to multiply both sides of the equation by the least common denominator, which is a 3, in order to clear the fractions. 3 times x squared over 3 would be x squared, plus 3 times 5/3 x would be 5x, plus 3 times 1 is 3, equals 0 times 3, which is 0. So I've cleared the fractions by distributing the 3 to both sides of the equation. So now a is 1, b is 5, and c is 3. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 5 plus or minus the square root of negative 25, positive 25 minus 12 all over 2. X equals negative 5 plus or minus the square root of 13 all over 2. So in this case, they've got the plus or minus notation because we don't have to enter it. So let's see, we want a negative 5 plus or minus the square root of over 2. Okay, so it's this one right here. All right. And there we go. Okay, let's see here. Let's take a look at this one, number 12. What would we do? We'd multiply both sides by the least common denominator, which is a 10. And then it would be just very much like number 11. Refer to the graph, fill in the blank. This is called a and blank function. Its graph is a cup-shaped figure called a parabola. So this would be a quadratic function. All right. The lowest point in the graph is 2, -1. It's called the what? Vertex of the parabola. Okay, so some vocabulary stuff here. The vertex line x equals 2 divides the parabola into 2 halves. The line is called the axis of symmetry. All right. Okay, here it says, find the vertex and axis of symmetry of the graph of the function. So number 16, f of x equals the quantity x minus 1 squared plus 9. So this function is in the form y equals a times x minus h squared plus k. Recall that the vertex is at hk, and the axis of symmetry is at x equals h, and it has to be an equation. Okay, now if a is positive, it opens up. If a is negative, it opens down. A equals 1, so it opens upwards. Okay, so the vertex would be at what? 1, 9. The axis of symmetry, x equals 1. And then, of course, the vertex opens upwards. So the vertex is at 1, 9. The axis of symmetry is at x equals 1. And this opens upwards. So many people miss this because they don't write an equation for the axis of symmetry. They just put in the number 1 and then they wonder what they've done wrong. It's an equation because it represents a dotted vertical line. Okay, let's see. Let's do number, let's go down here and do number 18. Okay. So the vertex is at hk, so that would be -4, -2. The axis of symmetry is at x equals -4. Okay. Any questions about that? So this is -4, space, -2. The axis of symmetry is at x equals -4. Okay. Now, graphing a parabola, graphing a second degree equation or a quadratic equation. What we need to do is, we've already got 1 point. We need a second point to use to graph, but the first point needs to be the vertex. Let's see, our equation, f of x equals x plus 4 the quantity squared minus 2. How about we pick a integer value right next to the vertex? How about -3? So f of -3 would be -3 plus 4 the quantity squared minus 2, which is 1 squared minus 2, which is 1 minus 2, which is -1. Okay, so I've got the vertex and one additional point that is on the graph of the function. Okay, so now I come over here and I choose the parabola button and I push it till it's blue. I don't want this one here, I want this one. Okay, I don't choose the points, I choose the parabola button. Then I come over here and I graph the vertex, -4, -2, and then one additional point after I graph the vertex, which is right there, -3, -1. Now, if over here you've got numbers that are fractions or something, you can come over here and you can adjust what the ordered pairs are going to be. You can come in there and retype it. Again, don't use mixed numbers. Use fractions, improper fractions, or exact decimals. Okay, so this should be the correct graph. And let's see here, submit answer. Alrighty, so there's the vertex, the axis of symmetry, and the graph. Any questions there? Okay, let's see here. How are we doing for time? Yeah, let's move on and do another one here. Okay, this says find the X and Y intercepts of the graph of the quadratic function. So this is number 20. And we have f of x equals x squared minus 4x. Okay. Minus 4x minus 21. We're to find the x and y intercepts. Now this graph or this function is not in the form y equals a times x minus h squared plus k. It's in the form y equals ax squared plus bx plus c. To find x-intercepts, set y equal to 0. To find y-intercepts, set x equal to 0. So to find the x-intercepts, we set y, or f of x, equal to 0. So now we've got this, okay? But to solve this second degree equation, we'll use the quadratic formula. Again, it's set equal to 0. So we've got a is 1, b is negative 4, c is negative 21. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals 4 plus or minus the square root of 16 plus 84 all over 2. X equals 4 plus or minus the square root of 100 all over 2. X equals 4 plus or minus the square root of 100 is 10 all over 2. X equals 4 plus 10 over 2, which is 14 over 2, which is 7. X equals 4 minus 10 over 2, which is negative 6 over 2, or negative 3. So we've got x-intercepts at 7, 0, and negative 3, 0. Now, be careful here. It says to put the smaller x value first. So this first one is going to be my negative 3, 0. And my second one is going to be 7, 0. Now, two common mistakes I've noticed. First of all, people ignore the directions here and they put the 7 first. Second of all, let's see, maybe I need a space there. They don't put the 0. They don't put in an ordered pair here. They just list the x-intercept, negative 3 and 7. And this form, they want an ordered pair. Okay. Now, let's go back and find the y-intercept. To find the y-intercept, we set x equal to 0. So that would be y equals 0 squared minus 4 times 0 minus 21. So y equals negative 21. So the y-intercept is at 0, negative 21. Again, you've got to include the 0 as part of the ordered pair. Okay. So there's that. Okay, let's see here. This is the same thing. And let's go ahead and do this one. Number 23, determine the coordinates of the vertex of the graph of the function using the vertex formula, then determine the x and y intercepts of the graph. If an answer does not exist, write capital D in E. So f of x equals x squared plus 4x plus 4. Okay, so for this, we've got a is 1, b is 4, and c is 4. When a second degree equation is in this form, the axis of symmetry is at x equals negative b over 2a, which would be negative 4 over 2 times 1, or negative 4 over 2, or negative 2. So the axis of symmetry is at x equals negative 2. Now, they don't ask for the axis of symmetry in this problem, but you have to find that to get the x value of the vertex. So from there, we're going to find f of negative 2, which will give us the corresponding y value. Negative 2, the quantity squared, plus 4 times negative 2 plus 4, which is 4 minus 8 plus 4, which is 0. So the vertex is at -2, 0. Okay. -2, 0. Now, X-intercept. Find X-intercept, set Y equal to 0. Okay. If we set Y equal to 0, we get the following. 0 equals x squared plus 4x plus 4. Now we're going to use the quadratic formula, and here's our A, B, and C. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals -4 plus or minus the square root of 16 minus 16 over 2. X equals -4 plus or minus the square root of 0 over 2. X equals -4 plus or minus 0 over 2. X equals -4 over 2. X equals -2. So X-intercept at -2, 0. We get a repeated root. There's just one. Okay. Oh, what do you know? The X-intercept is also the vertex. If the vertex lies on the x-axis, there can only be one X-intercept, right? Okay, the Y-intercept, we would set x equal to 0. So that would be what? 0 squared plus 4 times 0 plus 4, which is 4. So the Y-intercept is at 0, 4. Okay, 0, 4. Now, plot several points and complete the graph. So I'm going to start with a vertex, -2, 0. And then I need one other point. Well, let's see, the X-intercept is also the vertex, so I can't use that one, but 0, 4, that's another point. Oops, I didn't want to do that. Let's see here. Why is it doing all of that? I don't want to. It won't let me get rid of those points. Let's see, what can I do here? I want to clear this out. I'm making a mess. Okay. It won't let me clear it. Why is it doing this? This is not good. Tell you what, let's do this. Let's go submit answer and see what happens. Okay, so it's got this correct. Now it cleared this board off. So -2, 0, 0, 4. There we go. I don't know why it did that earlier, but that should be the correct answer. Okay, there we go. Let's take a look at some word problems. These are all pretty much the same thing. Here we go. So this is number 29. A fireworks shell is shot straight up with an initial velocity of 120 feet per second. Its height s after t seconds is given by the equation s equals 120t minus 16t squared. If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? All right, so we got the ground. We're going to fire this fireworks off, and we want it to explode up here at its maximum height. And it says how long after being fired, so that would be time. And at what height, that would be s, will the fireworks appear in the sky. So basically, we want the vertex of this parabola. So the first thing I'm going to do is put it in standard form. Okay, so A is -16, B is 120, and C is 0 if we need it. So x, or t, equals negative b over 2a, which is negative 120 over 2 times negative 16, negative 120 over negative 32. Negative divided by negative is positive. 120 divided by 32 is 3.75, and that's the time. Okay. Now, how do we find the S value? We put in 3.75 for the time. So S equals negative 16 times 3.75 squared plus 120 times 3.75. Calculator time, negative 16 times, let's see here, 3.75 squared plus 120 times 3.75, and I get 225. So the vertex is at 3.75, 225, okay? And this is feet. So let's see here. The time would be 3.75 seconds, and the units are already labeled there, and the height, 225 feet. Okay, let's take a look at number 30. Let's see, 30, yeah. We'll just do these application problems as much as we have time for. So this is number 30. From the top of a building, a ball is thrown straight up with initial velocity of 32 feet per second. The equation S equals negative 16t squared plus 32t plus 48 gives the height S of the ball t seconds after it is thrown. Find the maximum height reached by the ball and the time it takes for the ball to hit the ground. Okay, so now we want the maximum height, which is S, and we want the time it hits the ground, which is the t-intercept, so to speak. Okay, so we need part of the vertex and one of the x or t intercepts. Okay, so to find the S value of the vertex, I have to start with the t value, which would be where the axis of symmetry is, right? So we've got A is negative 16, B is 32, and C is 48. T equals negative B over 2A, which is negative 32 over 2 times negative 16, which is negative 32 over negative 32, which is 1. So the time it takes to reach the top is 1 second. They don't ask for that though, but we need that because now we're going to go back and put 1 second in for time, which is negative 16 times 1 plus 32 plus 48, which is negative 16 plus what, 80, which is what, 64. Okay, so the height is 64 feet. Now, we want the time for it to hit the ground. When does it hit the ground? When the height is 0. So now we're going to take this equation and set it equal to 0. And we're going to use the quadratic equation. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. T equals negative 32 plus or minus the square root of, let's see here, 32 squared is 1024. Then we've got negative 4 times negative 16 times 48. So that's plus 3072 all over negative 32. T equals negative 32 plus or minus the square root. Let's see, 3072 plus 1024 is 4096 all over negative 32. And let's see if that's a perfect square. It is. Square root of that is 64. So I've got, let's see, t equals negative 32 plus 64 over negative 32, which would be 32 over negative 32, which is negative 1. And t equals negative 32 minus 64 over negative 32, which is negative 96 over negative 32, which is 3. So t equals negative 1 and t equals 3. Now, t equals negative 1 would actually be that point right there. But the ball didn't, or is it a ball? Yeah, the ball didn't start on the ground. It started 48 feet up in the air. So even though we're finding that t value, it's negative, so that doesn't work. It's the 3 seconds. That's the point right there when it hits the ground. Okay. Yeah, let's see how that is. Okay. And now let's take a look at another application problem, number 31. Suppose you're a police officer, patrol officer, and you have a 292-foot long roll of yellow do not cross barricade tape to seal off an automobile accident as shown in the illustration. What dimensions should you use to seal off the maximum rectangular area around the collision? So we've got this rectangle, okay? And the total perimeter is 292 feet. If we were to cut it in half, that would be what, 146 feet? Is that right? 192 divided by 2. Yeah. So that means this piece plus that piece add up to 146. For some reason, I'm just going to check that. Okay. So let's say we call this X. Then this would be 146 minus X. The two pieces add up to 146. Okay. Now, it says, see, we want to find the maximum rectangular area. Well, the area would be the length times the width. So the area would be 146 minus X times X, or the area would be 146x minus x squared. I'm going to write it as a function a of x, and I'm going to put it in descending power standard form. Okay, so there's our equation. Now note, that is a parabola opening downwards. Okay, this is x and this is a of x in terms of the axes. We want to find the dimensions that would maximize the area. Well, since this is the area, that would be the maximum. So we need to find the vertex. Okay, a is -1, b is 146, x equals negative b over 2a, which is -146 over 2 times -1. -146 over -2 is positive 73. So x is 73 feet. 146 minus x would be 146 minus 73, which is also 73 feet. So the dimensions are 73 feet by 73 feet. Okay, in this situation, this is confusing. I've talked with the WebAssign people, didn't get an answer back, because it makes you think that they're different lengths. But in fact, we see that this is a square. So basically, you know, they could have said one side, the other side, but they're both going to be 73 feet. Now, how do you find the maximum area? Well, there's two different ways. You could take 73 times 73 and get 5,329 square feet, or you could find a of 73 and plug it in here, and you should also get 5,329 square feet. 5,329 square feet. And finally, one more application problem. Number 32. In this case, we have 3 sides of a rectangle up against a river. And the total length of the 3 pieces of fence is 1,020 feet. Since this is 3 sides of a rectangle, these 2 sides have to be equal. So this third side here would be 1,020 minus 2x. Okay. Again, we want to maximize the area. So the area would be 1,020 minus 2x times x, which is 1,020 x minus 2x squared. Again, I'm going to write it as a function and put it in descending powers, the variable. And we're looking for the dimensions. So I need to find x. So x is negative b over 2a, which would be what? Negative 1,020 over 2 times negative 2, which is negative 1,020 over negative 4. And what do we have here? Negative divided by negative is positive. 1,020 divided by 4 is 255. So this is 255, and this would be 1,020 minus 2 times 255, which is 510. So let's see here, 255 and 510. And again, notice smaller side, larger side. So if you switch these around, it's going to mark it wrong. Okay. Anyway, that's all I have for today. I'll be back this afternoon at 1:15 with an office hour. Tomorrow we'll wrap up the review. We'll take a look at chapter 11, and then your final exam is on Monday. So have a great rest of the day. I'm going to turn off the recording now.